Hello friends, welcome. Friends, today I am doing a video which is not my core expertise. To be very frank, let me tell you, this is not my core expertise. But I am anyway doing this video because as a layman with some understanding about technology and software, I tried my level best to read this paper, DeepSeek research paper. Now, DeepSeek has become a buzzword with everybody. People are going crazy, right? And the stocks of multi-billion-dollar companies are falling. Everybody must be aware of this. I don't think that anybody who is interested in the tech space, even as a layman, must be completely oblivious to this happening which took place just recently. And that has created havoc in the tech industry. Now, friends, when I was analyzing this situation, and I thought that rather than just going and listening to videos, let's go and read the research paper, because this research paper is available in the website of DeepSeek. Now, this research paper is quite complicated, and I really don't understand each and every aspect of this research paper. So, what I am planning to do is, I will be reading this research paper from the point of view of a layman. That's what I'm going to do, and trying to extrapolate some of the concepts that has been laid out in this research paper, which will have a huge impact on our lives as individual, as ordinary citizens. And let's understand this step by step so that you can appreciate what I'm talking about. And mind you, friends, just with a caveat, there will be certain things which I might go wrong, I have misunderstood. So please bear with me, but the larger story is pretty clear. So I think if we go through the paper as a layman, we will be able to understand the implication. And I will like to go through this video with you to understand the implication. That's all we are going to do in this video. So be with me, and I think you will find this very interesting. So let's forget about the abstract. Let's go in the body of the main paper, because this paper has been very, very nicely written. This paper has been written in such a manner that even a layman, if they can read this paper, they will be able to understand what is going on. Okay, that's how the research paper should be written. Because if the research papers are written in a manner that you can't even understand any head and tail about the research paper, then what is the point of writing a research paper? Okay, so let's understand this. I will point to some key words in this research paper. First is post-training. So let's look at this post-training. This first sentence, which is absolutely crucial. What it is saying? Recently, post-training has emerged as an important component of the full training pipeline. You understand? Just focus on the word post-training. This is a very important word, post-training. What does it mean? It means that whenever you are training a model, the first level of training a model does not lead to any kind of usefulness. So you need to do some post-training in order to make your model useful. Why? Why should you do post-training? This is in the second line. This line basically says it has been shown to enhance accuracy, reasoning tasks aligned with social values. Which means that if you really want the model to reason, just kind of laying out words and sentences and predict sentences, what is going to come next, it is important for you to do post-training. Now, with this post-training, there is a very important component, in this reasoning, there is a very important component, which is basically is a technical term, which is there, chain of thought. Now, chain of thought, which you see here, is a technical word. Now, my understanding of chain of thought is that you hold the model to wait. Means, suppose, let's say if you are asking a complex task for the model to do, model will not immediately output the result. It is going to do some computational in the background, and then after thinking, that process is called thinking. After that, it is going to lay out the result where the reasoning task that it is performing is going to be more accurate, right? That is what is called probably the chain of thought. This is what they are mentioning, which is a part of the reasoning process. Now, what they are saying is that in order to make a model reason, what you do? You need to basically do some kind of training, and this is done through supervised training data. Now, there is an important word called supervising the training, for which you need supervisory help and you need a lot of data and a lot of computational power, which makes the process very, very complicated. Are you with me? Because actually I am basically talking to myself, whether we are understanding each other or not, right? So this is supervisory training. So what this model has done, it has basically bypass or optimize this supervising training with a process called reinforcement learning. Now, what is reinforcement learning? Now, reinforcement learning is also a technical term, and I will not like to get into that technicalities because my interest is not to go into technical. There are good scientists and mathematicians who will do this work. I'd like to understand what reinforcement learning is and how it is different from supervisory learning, right? So what they have said is that if you look at this particular paper, you will find that there is an algorithm, and this algorithm is called group relative policy optimization algorithm. Now we don't have to understand this algorithm. This is too complicated for anybody to understand. So what is this algorithm? This algorithm is nothing but a process of reinforcement learning algorithm. So this algorithm learns on itself. It does not use neural networks to do the learning because it is clearly pointed out in this paper. It says that we do not apply the outcome process of neural reward model to develop DeepSeek R0 because we find that the neural reward model may suffer from reward hacking. Now, again it is getting technical. Let me make you understand. Any model that you train, you actually have to have a certain way of optimizing your output. You're going to the output so that what you want, the model should be able to deliver. So instead of using, so there is one way actually is to basically do back propagation. So there is an output. You send the output back to the input and the neural network weights are going to get adjusted and the output is going to fall in line depending upon what your end goal is, right? That is how generally models are being trained. Here, there is a different way of training it, which is the algorithm that I showed you. So what they do is they actually set up certain amount of kind of rewards. So those rewards are dynamically changed in order to drive the model to a certain output. For example, if there is a mathematical problem and a mathematical problem has got a very specific output, you know that output. So you need to drive that model to that output by setting up a mechanism of reward. So that mechanism of reward, which they do it mathematically, will drive the model towards that, which is different from setting weights of the neural network, which is basically performing the part of the model itself. Because when the data passes through the model, the weights, which is part of the system, will have to be adjusted to drive a particular output. So there has to be a back propagation of data in order for the process to work. Back propagation means whatever is the output, you feed in back to the input, right? But here, what they're doing is basically they may be doing some kind of back propagation. I have no clue. This equation that this particular thing is nothing but almost similar to that. But the way to optimize is different. Now, let's get to the core of the discussion. One is that reinforcement learning, what they're saying is much more optimal compared to supervisory training, which is much more costly and difficult and requires a lot of complex and it is a lot of data infrastructure and makes the whole process complex. And this is autonomous. They are also saying that this model, this reinforcement learning is an autonomous learning, self-evolution reinforcement learning process. It's an autonomous process, which is some kind of a science fiction. If the model learns by itself, right, because of the reward mechanism, it's quite a significant outcome. Let me tell you that it is not so easy. And there are certain things which they are saying in this paper, which is really, really very, very concerning or very exciting. For example, the AHA model. Let me just show you one thing. Where is that line which I saw, which is very, very interesting. What they are saying is something which the model did, which they really could not visualize. I have not underlined it. I'm sorry. Forget about it. So let's come to other important part of the discussion, which is called distillation. Now here is where I get very much interested. Distillation is a very, very important part of this whole process. Now what is distillation? Let me just come to the distillation. Yeah. Distillation. This is very, very important. I can tell you that it is so important that, nothing comes closer to this, right? Distillation means smaller models can be powerful too. Now, what is the problem that we are facing today in our AI evolution is that models which get smaller becomes very inaccurate. Now, why do you need smaller models? You need smaller models to run on your desktop computer, on your mobile phones, because you want the mobile phones to deliver AI output without talking to the network, to the cloud. Because as soon as you go to the cloud, the whole process becomes very, very costly and it requires does a lot of latency. But if you want to do real time, analysis on the mobile phone, which doesn't have that much about a computational power, you need smaller models to function very, very effectively. So what this paper is telling us that they have been able to distill smaller models which are more powerful than their counterparts. The OpenAI, the Llama and the Microsoft and others, Meta, etc. by a significant margin in the benchmarks test than compared to the models which have been learned, which have been created using other processes. And this distillation can actually opens a very powerful window to applications which are unthinkable today. Let me tell you this, because I am able to visualize from a mobile industry, because that is where my expertise is, that today the basic problem in mobile is computational power. You really cannot have so much amount of computational power in mobile because the battery is limited, the chip is limited, everything is limited, and you have to optimize on everything. You cannot run, big models in your mobile phone in a standalone manner. And if this becomes the reality, the smaller models can become powerful too. You can imagine that what kind of applications that you can bring on the table, right? Now, the other important point is, anyway, I don't want to get you to all the papers, because there are experts which are all the day doing that, right? There is no point in me to basically talk about it, because neither I understand nor I have the capability, nor I am interested in doing that, because it is not going to add any value, right? But the point here is that, look at this. This model is an open source model. It has all the codes available in GitHub. Everybody can pick the code and actually start running with that code, right? So therefore, how do you block a model like this, right? If somebody says that US is going to basically block this model, not allow this DeepSeek to get propagated throughout the world, it is not going to happen. What is going to happen is, this model, the techniques that they have followed in this model is going to be copied very soon by others, right? And that will make the AI industry much more powerful, capable, optimized, and able to do things in a much more conserved, resources which are in a conserved manner, rather than expanding the resources, running big. Like, for example, if you are going to run a Microsoft window for which you need your PC to be upgraded all the time, it makes no sense. We want algorithms to be sharper, powerful, so that those can be leveraged on devices which we are holding in our hand. Then only the power of AI, the true power of AI is going to unlock. If you recall the days when mobile broadband came into being, the power of the mobile handset actually was able to deliver, which the common man could not even think when he was using a laptop, because you are stuck to a particular place. This is what I think is going to happen in the future. Because of this, smaller models can be powerful too. You can understand that. One is the training process, which is a very complicated thing. I'm not interested much in that. You can do whatever you want. Let's do that. You can train models in a much more conservative manner, in prices which is unthinkable, insane, and all those things you get. But if you are going to create models which can run in a very optimal hardware, it does not require those GPUs, etc. You are bringing the AI cost down to such a level that it becomes the part of the common man, and everybody can afford, and everybody can come out with unthinkable applications. That is where the main essence is. Now, whether those server farms are going to become obsolete, whether those investments which have been done are going to be obsolete, absolutely not, because you need computational power anyway. What we are trying to do now with these, what they are trying to do, because I am nobody, I don't have these kind of expertise which these people have. They are super intelligent people. what they have brought in the table is an unthinkable thing which was not there in past. The paradigm shift from what we were thinking the AI needs. AI needs huge data server farms and all those things to run. If this can be run standalone on my computer, on my mobile phone, think how the world is going to change. That's what I want to. So if you can run a model in a smaller device, then if you have a big server farm, then you can do many more things which is unthinkable. Those server farms are not going to get wasted, right? They will be able to do things which are much more, which they currently are not capable of, and you really don't require to waste money to put so many servers and use so much amount of power, which was becoming a main bone of contention in AI. So those investments can be saved. So anyway, it is not about who wins the AI and what the US is thinking, whether the NVIDIA stock is going down or Microsoft is concerned. I am not concerned about those. What I am concerned is what is this technology, this particular announcement is going to bring on the table if it is true. Now, whether they are telling the truth as per as the training cost, whether they have other training tools available or not, that is not the point. You need to just test this capability. Smaller models are distilled through larger models and they can be powerful too. That is where I think is the main part of the story which I am interested in. The rest of the things are definitely a point of discussion where many people will be talking and discussing. But my point is that we need to have models which are smaller, which can run on form factor, which do not have the capability to do large computation because of various factors which we cannot implement on those smaller devices. Thank you, friends, for your time. I don't want to get further into this because I will be totally exposed because I am an illiterate in this area, let me tell you. But from a logic point of view, I'm trying to see this and therefore I made an attempt to read this paper. Thank you very much for your time, friends. I will come back with a new video next time.